Hi, today we're going to be talking about chemical reactions. All right, finally. Um, Basically, a chemical reaction is the process by which one or more pure substances are changed into one or more new pure substances by the reorganization of component atoms. All right, so this is where we're talking about how, remember, pure substances are either compounds or pure elements. And if you, when you're starting off with some pure substances, the bonds will break, new bonds will form, and you'll end up with new pure substances. This is also known as a chemical change. All right. Now, chemical reactions involve a rearrangement of the ways atoms are grouped together. The products of a reaction are made up of the same number and kinds of atoms as were present in the reactants. And remember, products are the substances, the new substance that are formed in a chemical reaction. It is always to the right of the reaction arrow, whereas the reactants are the starting substances in a chemical reaction shown to the left of the reaction arrow. And what happens is that the bonding patterns of atoms are merely rearranged. All right, bonds are broken and new ones are formed. It is you cannot destroy or make new atoms in this process, at least not in a chemical reaction. Remember, that takes a nuclear reaction to do. But in a chemical reaction, the bonding patterns are merely rearranged. All right, so you end up with the same number and types of atoms that are present in the beginning must be there at the end, no matter what. All right, and that's why we can balance equations. But now, how can you tell that a chemical reaction has actually occurred? Well, it can be difficult sometimes because most of the following indicators can be produced physically. All right, so there are a number of indicators that you can look for, and think of these kind of like clues that, hey, look, if I see this, probably a chemical reaction has occurred, but not necessarily. First of all, a color change in the reaction system. Now, I'm not talking about an obvious color change, like if you have green paint, if you have blue paint and you mix it with yellow paint, it ends up with green paint. I'm saying, well, what if you have a blue solution and you mix it with a yellow solution and it ends up, I don't know, orange or red or something unexpected. So in a way, it's kind of like an unexpected color change. All right. Next is the formation of a solid precipitate. Now, precipitate, remember, is a solid that comes out of solution. When you have a couple of reactants, they come together. If one of the products is a solid that will not dissolve in water, it will come out as a precipitate. Now, when you see a precipitate, if you're actually doing this experiment, what you usually see is you have a couple of clear solutions. They may be colored, but still clear. When you mix them together, if it gets all cloudy, that means that a precipitate has indeed formed, okay? Now, another type is the evolution of a gas. Bubbles form. So like if you have a metal and you put it in a solution, you start seeing a bunch of bubbles coming. That's a good example of an evolution of a gas. Now, a fourth one is the evolution or absorption of heat. So if you can feel it, if you can feel that it gets hotter or if it gets colder, then that is a good indicator that a chemical reaction has taken place. Remember, if it gets hotter, that means it's releasing energy, it's exothermic. If it is getting colder, it's absorbing energy, and that means it's endothermic. And it could also emit light. Now, it could emit light as in a flame, where it does both production of heat and the emission of light, or it could be something like a glow stick, where it just emits light. All right. Now, since each and every one of these can be, as it were, reproduced physically, all right. For example, the whole, hey, look, you got yellow paint, blue paint, boom, it makes green. Is that a color change because of a chemical reaction? No, that's actually a physical change. Formation of a solid precipitate. Well, what if you get water and make it really cold? Well, it turns into a solid. Is that a precipitate? Again, it's hard to tell. Sometimes. Evolution of a gas. I mean, heck, you open up a soda, open up a Sprite or a 7-Up or something, and it produces a bunch of bubbles. That's physical because it is the gases are coming out of solution. It's not because there's a chemical reaction. And evolution or absorption of heat. If you turn on a heater or a toaster, if you look inside a toaster with the little wires and they start glowing, is that a chemical reaction because it's giving off heat and light? No, it's not. That's just a physical process. So all of those can be reproduced physically, and it can be kind of confusing at times. And therefore, the only definite proof that a chemical reaction has in fact taken place is the formation of a new pure substance from the atoms present in the reactants. So you have to test it and see if you end up with something new. It's only 100% surefire way. Now, chemical equations. A chemical equation represents a chemical reaction. All right? It uses formulas of the starting substances that react and the new substances that are formed. So it gives the chemical equations, chemical formulas of the reactants and products, and it puts them in the appropriate order. Now, basically, it describes the type and number of atoms that are rearranged during a reaction. Remember, reactants are shown to the left of the arrow, products are shown to the right. And they are separated, individual reactants are separated with a plus sign, just like individual products are separated with a plus sign. Now, you could have something like this, which is known as a skeletal equation, or an unbalanced chemical equation that just tells you what the reactants are and what the products are. You could have a word equation that doesn't use formulas. It just uses words and might just describe it in a sentence, like methane reacts with oxygen to produce carbon dioxide and water. But the best way of looking at it, a best representation would be a balanced chemical equation. Because not only does a balanced chemical equation give you what the reactants and products are that are part of the reaction, but it also indicates how many, how much, and that is a much more realistic representation of the chemical reaction. Now, another thing that it can do is it can give you more information. All right? Think of equations kind of like a recipe in that they show the types and amounts of reactants and also the expected yield of products. I mean, if you've ever made chocolate chip cookies from scratch and you're looking at a recipe, it tells you, first of all, what the reactants are. You got your flour and sugar and egg and salt and all that good stuff. And it tells you the amounts, all right? How much flour, how many eggs, and so forth. And also it tells you the expected yield. Yield is an old-fashioned way of saying product. If it is a noun, it's product. If it is a verb, then it is to produce. To yield something is to produce. So the expected yield of products is like, how much do you produce? What do you produce? How many chocolate chips do you actually make? All right, or can you make in a recipe? So equations can also indicate the reaction conditions and the physical states of the reactants and products. Some reactions do not occur unless you also add heat. Some reactions need certain conditions that need to be met. All right. You will often see, for example, the physical states. These are often in a chemical reaction equation, and they come at the end of each substance, and they're like a subscript and in parentheses. An S for solid, L for liquid, G is in it's a gaseous form. AQ indicates that it has been dissolved in water. In other words, an aqueous solution. Now, aqueous solutions are often required for ionic compounds, for example, to react with each other. As solids, they wouldn't be able to react. But when you dissolve them in water, the individual ions can have access to each other, and that allows for the chemical reaction to occur. So it often will say what states of matter the substances must be in. Okay. For example, here, solid potassium reacts with liquid water to produce hydrogen gas and potassium hydroxide solution. In other words, dissolved in water. That's why it has the AQ after it. All right. And that is all I want to talk to you guys about for chemical equations. All right. Good luck. And again, if you have questions, please come to tutorial. Thank you.